welcome to this lesson, episode 2 of construction of chemical formulas and equation. In this lesson, we're going to look at how to construct chemical formulas. In our introduction, let us define a chemical formula. A chemical formula consists of a symbol or symbols showing the number of atoms in one molecule of an element or a compound. Therefore, by the end of this lesson, you will be able to construct the formula of compounds involving simple elements, compounds involving radicals, and compounds involving transition elements, TE. Let's look at the general steps to consider when writing the chemical formula of common compounds. Number 1, you are supposed to write the symbol for the combining elements or radicals. Number 2, write the valency of each element or radical at the top of its right-hand side. Exchange the valencies of the combining elements and radicals by writing them at the bottom right-hand side of the element or radical. If the number is 1, do not show it. In some formulas, radicals are put in brackets followed by a small subscript. Now, these rules are for you to follow. However, I'm going to explain these rules using practical examples. So please follow through so that you are not left behind. All right, let's look at formulas involving simple elements. And these are the examples that you're going to run with. So the first one here, they have said sodium chloride. Now we know that a compound is just a composition of 1 or 2 elements, okay? Simply a composition of 1 or 2 elements. Now, so these formulas, you need to read the formula. Number 1, you need to read the formula. So this is us giving answers. Now we are working out A. So read the whole thing and identify the elements that are in there by sound. So for example, here we are reading sodium chloride. So by sound here, I can tell that there is sodium and there is the chloride. So when I identify, I'm going to write the symbol. So sodium, according to the periodic table, is Na. Then chloride, according to the table of radicals, should be Cl. Okay, so I write them. Then I'm going to write them again down here, Na and then Cl. Then the next thing I'm going to do, I'm going to write their valencies as a superscript. So the valence of sodium is 1, so I'm going to write it here as 1. The valence of chlorine, chlorine is in group 7, so it's 1, so we're going to write 1 here. Then afterwards, we are going to interchange the valencies. So this valency will go to this one. This valency will go to this one. So when you are writing them after exchanging, you should write them at the bottom as subscript. So I'll write 1, 1. Now, if the valencies you are swapping is 1, 1, we know that 1 is an invisible coefficient. We are supposed to ignore it. So here, we are just going to write the formula as NaCl, and that's it. We ignore the ones. Let's go to B. So we are solving B. Again, we're going to identify the components of this formula by name. So here it says calcium chloride. So you can see there is calcium. So we're going to write our Ca, and then chloride, it's Cl. So we write our Cl. Then afterwards, we check for the valencies on the periodic table. Calcium is in group 2, therefore the valence is 2. Chlorine is in group 1, therefore the valence is 1. Then you write the symbols again at the bottom so that you can easily swap. So this one here will come here. Then this one will go there. So here we're going to have a 1. Here we're going to have a 2. Then you write your answer as Cl2 as a subscript. So this is the formula that we have right there. Okay, 1 is invisible, so that's why we've ignored it. But 2, you leave it as it is. Let's look at C. C, let's read again. It says carbon dioxide. Now, dioxide just means from oxygen, meaning 2 oxygens are present. So what you're going to do here is you're going to write your carbon, which is C, and your oxygen, which is O. Then you write these ones again, C, O, and then on top here, you're going to put the valencies. So carbon is in group 4, therefore it has a valence of 4. Then here, oxygen is in group 6, sorry. So 8 minus 6 is 2, therefore it's going to have a valence of 2. So if you don't have the knowledge about valencies, this you cannot do. Afterwards, you're going to interchange. This valency will come here and that valence will come there. So we're going to have a 2 here and then we're going to have a 4 here. Now, one of the rules when constructing chemical formulas is that we should reduce the valencies in their lowest terms. So you look for a number that will go into this valency and this valency without leaving a remainder. If that number is there, then you go ahead just to reduce. So here we can say 2 into 2 is 1, 2 into 4 is 2. So 1 we ignore it, we're just going to say CO and a 2. So that is the formula for carbon dioxide, and that is where it comes from. Let's go ahead and look at C. Okay, so C, let's just see if we can create some space and solve for C instead. So yes, we've created this space and let us solve for C. So C, here they are saying calcium oxide. So again, there is calcium and there is oxygen. So calcium is going to be Ca, then oxygen is O. Calcium is in group 2, so it has a valence of 2. Oxygen also in group 6, and 8 minus 6 is 2, so the valence will be 2. You write these ones again, Ca and O, and then you interchange. This one comes there, and that one goes there. So we're going to have a 2 here and a 2 here. So again, 2 into 2, 1. 2 into 2, 1. You reduce them. So 1, 1 you ignore. As a result, the formula will be CaO. And that will be the formula for what? Calcium oxide. All right, that was formulas involving simple elements. Let's look at formulas involving radicals and see what will come up with. So please, it's about following the rules. Make sure you understand the rules and everything will be okay. So let's read here. Again, our A, start our A from here. So here it says potassium carbonate. Now remember we are dealing with radicals, and I did mention that you are supposed to memorize the radicals. So your first task is make sure you come up with that mnemonic that will be helping you to memorize the radicals. All right, so potassium, there is potassium and there is carbonate. So carbonate is a radical. So we're going to write our potassium, which is our K, and our carbonate, which is our CO3. Then remember, this carbonate has a valence of 2, so you write the valence of 2. Then our potassium has a valence of 1. When you write these species again, we are going to swap. This one will come here, these two will go there. Now, these radicals, we said they are incapable of independent existence. For lack of a better term here, I'm going to say they are selfish. Radicals, they just want to be the way they are. If they sense anything coming towards them, they need to protect themselves by enclosing themselves in brackets. So here, because there is this valence that is coming, they are going to sense it and they are going to enclose themselves in brackets so that when this valence comes, it will be outside. Then this one will go here, it will be K2. Now, there is a catch here. When the valence that is coming, when they sense that there's another valence that is coming, the radicals, they protect themselves. However, if they discover that the number that has come there is 1, then 1 is not a threat. They deprotect themselves because 1 is not a threat and 1 is ignored anyway. So the final answer here will just be K2, okay? K2 and CO3 without any brackets, because the one which has come in is 1. If it was another number coming through, then it would have remained in brackets. Okay, so let's look at the second example here. B, they are saying, so we look at B. B, they are saying ammonium carbonate. So this one is made up of radicals only. So ammonium has got a valence of NH4. The valence is NH4. The formula is NH4 and the valence is 1. Carbonate CO3 and the valence is 1. So we interchange. Now, these both are radicals. So when you write them again here, NH 4 and CO3. Now, when they sense this guy which is supposed to come and this other one which is supposed to go, when they sense these are radicals, they will protect themselves. So when this one comes, it will be outside. Then this also is a radical, so it will protect itself when it senses a valence coming. So this one, this two will be outside. Now, the difference between the two here is this is a number 2, so this will remain in brackets. But if it is 1, then the brackets will go. So therefore, the final answer here is going to be NH4. It's going to be NH4. You enclose, you write your 2 here, it remains, and then CO3, and this one will be, so remember this is capital letter O, so CO3, and this will be your formula. So please take note, the difference between these two is that here there was a 1, and when it's a 1, then it's not a threat, then there will be a need to remove the brackets. But if it's not 1, it's any other number such as 2, 3, 4, 5, 6, etc., then it has to remain in the brackets like we have done this one here. Let's quickly look at other examples. So we've done A, we've done B. Let's see if we can also look at C. So once you understand using these examples that have been carefully selected here, there is no way you can fail to solve any formula at all. So these are all the rules that are present there. So let's go to C. C says sodium sulfate. So again, there is sodium, so you write Na with a valence of 1. Then sulfate is a radical, which is SO4 with a valence of 2. So you write these guys again, Na, and then SO4. Now remember what you said here, there is exchanging, so the 2 will just come here, and then once these guys, they sense anything, they are going to put themselves in brackets, then the valence will be outside. And also another important aspect that you need to remember is you need to reduce the valences. So let's finish this one. Let's finish this one before we go to that one. So this one will be Na2, the final answer, Na2, then SO4. Have you noticed we've removed the brackets because the number is 1. But let's look at this one just to emphasize my point. If it was calcium sulfate, for example, if it was calcium sulfate, this is an extra example I've included, it would have been Ca with a valence of 2, then sulfate SO4 with a valence of 2 as well. So these will exchange, the 2 will come here, then the sulfate also, there is another 2 which will come from there. So there is exchange, this goes there, then this goes there. So it will protect themselves, and then there's a 2. But remember, there's a part for where you are supposed to reduce the valences. So here, we're going to say 2 into 2, 1. 2 into 2, 2 into 2, 1. Now, this number was initially 2, but after reducing the valences, it has come to 1. Please, never make a mistake of you wanting to reduce this valency and this number that belongs to a radical. Radicals are not supposed to be tampered with. So the 2 or any number that belongs to a radical is supposed to remain the way it is and not to be tampered with. So that's why this 4 is not being touched. So please take note of that. So because here we've cancelled 2 to give us 1, 2 to give us 1, the final answer would just be like this. Okay, the final answer could just be like that. All right, so actually that was D. So the one we did here was D. I've just realized that it is here. And then let's look at the last one here, which is ammonium sulfate. So ammonium sulfate, again, we're going to have NH4. So NH4 and the valence is 1. Then we have the PO4, okay, PO4 with a valence of 3. Then you interchange those. We're going to have NH4, okay, NH4. And then we have the valence of 3 coming here. Then PO4, we leave it like this because the one that is coming is 1. So even if we protected it, we would have deprotected anyway because it is 1. So that is how this one is supposed to be solved. Now, the last part of this episode is where we are trying to construct formulas involving transition elements, which is not that different from what you're doing. So let's look at the first one here. They are saying iron 2 sulfate. So we know we have iron and we have sulfate. So iron is going to be Fe. Now in this formula here, in the brackets here, we have a Roman numeral 2, which means iron has got a valence of 2. Then the sulfate, SO4, also is a radical with a valence of 2. So we swap those ones after we write these ones again, Fe. So the 2 will come down here. Then the SO4, this one is going to be protected because a 2 is coming. But remember, it's the valences that we reduce. The radicals, we don't tamper with them. We only deal with the radicals. So 2 into 2, 1. 2 into 2, 1. As a result here, the formula will just be FeSO4. And that will be the formula for this one. The same one here, in the brackets for B, they've changed to iron 3. So here, it is going to be Fe3, then SO4 with a valence of 2. So we write these species again, Fe, and then SO4. Okay, so these 2 will come peacefully here. Then the 3 will go to this radical. So once the SO4 senses, so this is SO4, sorry, make sure you see SO4, the 3 will be outside there. Now the question is, can we reduce 2 and 3 any further? No, we can't. So this is where it ends. So you just rewrite the formula nicely and close together like that. So this is SO4 close brackets and a 3, and that is your answer. So that is how you are supposed to find the formulas of different compounds. Now I'm going to leave C for you to try out. Okay, I'm going to leave C for you to try out. You can even comment it in the comment section or anything, but if you follow through this video, this is all the concepts there is for better understanding of construction of formulas. Thank you so much. Keep watching.